Okay, guys, we're back, and we're going to begin with where we left off in the previous slide, where we were talking about what is needed to make sure that we know two triangles are congruent. So we have here the statement that says if the triangle ABC, the green triangle, is equal to the is congruent to the XYZ uh, pink triangle, then all of the following six things need to be true, okay? All the corresponding angles, A and X, okay, B and Y, C and Z, and all the corresponding sides, AB, XY, okay, need to be congruent. BC needs to be congruent to YZ, AC needs to be congruent to XZ. So if the two triangles are congruent, then six parts of one are equal to six parts of the other, okay? Which means if we want to show that two triangles are congruent, we need to show that all six parts of one are equal to the corresponding six parts of another until we come across a couple of these postulates, which are going to trim those. So here's what we're looking at, okay? There are three postulates we're going to help us out, and they're going to reduce it from six things that have to be shown to three things, okay? That is, one is called the side. Simple enough. If all three sides of one triangle equal all three sides of the other triangle, boom, the two triangles are congruent. Okay? The side angle side, and SAS, that is the angle in between two sides. If two sides in the included angle, that's what we mean by SAS. If two sides in the included angle of one triangle are congruent to the corresponding two sides and included angle of another triangle, the triangles are congruent. And the ASA, the side in between two angles, okay? If that can be represented, the triangles are congruent. So we're gonna show you these, okay? And we'll actually have a chance in Sketchpad to work with this. So just give it a chance. Let's go through this first, though. Okay. So let's go through those in the next three sides. Okay. Postulate 4.2 says, okay, look, these three sides, okay, that is AB matches up with YX. We can tell by the single slash. We can tell by the double slash that BC and YZ match up, and the triple slash matches up the remaining AC side with XZ. Okay, we're back. All right. Now, postulate 4.2 says if the three sides of one triangle are congruent to the corresponding sides of another triangle, the two triangles are congruent. You don't have to go through the angles. If you could just show that the sides are congruent, you've got it done. That's simple enough. Okay. So since the corresponding sides, as labeled here, and as with the hash marks are shown up here, since they are congruent, the two triangles are congruent. And make sure that however you order this, A, B, C, the AB, the first two letters, match up with XY, the second two letters, okay, which is saying AB side equals XY, okay? So this is the triple S postulate, the SSS postulate, okay? Now, here's what we mean by two sides and the included angle. It's the angle formed by those two sides, okay? So in this case, if two sides in the included angle of one triangle are congruent to the corresponding two sides and included angle of another triangle, the triangles are congruent, okay? And there you have it, all right? Two sides and the angle forming by those two sides, okay? So in this case, since BC is congruent with YZ, since AC is congruent with XZ, and the angle formed by them, okay, mainly angles C and Z, if that condition is held, then the two triangles are going to be congruent via the SAS. The SAS, that's the angle in between the two sides. That's postulate 4.3. Okay? And finally, we have the ASA, which as you can see down here, the way it's marked, okay? It's the side in between two angles. It's the side in between two angles. If the side between two angles of one triangle, that is, if two angles in the included side of one triangle are congruent to the corresponding two angles and included side of another triangle, okay, then you have congruence, okay, by the angle side angle, okay. Now, just so that we're safe, okay, I showed you something that is not angle side angle, okay. So here are two sides and an angle, okay, but they are, or I'm sorry, this is two angles and a side, but it is not the side in between those two angles, okay? So this is not going to be, okay, your ASA. There's two angles and the not included side, two angles and the not included side. You can't, if you mark it off that way, it's not sufficient for triangle congruence. Let's go through a couple proofs, okay? We're going to start with this. We're going to start with this statement: BD bisects a angle B, okay? And with that, uh, and we also have that BD is perpendicular AC. We want to prove that ABD, trace it out, and CBD, okay, that is the left and the right triangles are congruent. The left and the right triangles are congruent. So notice what I do. I mark it off according to the information provided, okay? The BD bisecting angle B allow me to indicate these two angles up here are congruent. Okay, the two angles of B are congruent. I also had the perpendicular condition, which meant that I could put the box down here to indicate that the right angle exists. Okay, uh, and they also have this common side. Okay, which they share. So, do you think we have triangle congruence? Okay, look and see how the triangles would match up. Okay, how would they match up? It looks like we would do a flip across BD, in which case, okay, these angles would coincide and the right angles would coincide. So it looks like we're going to have a case of angle side angle. Okay, remember, the only way to claim that the side is equal to itself is the reflexive property, okay? So as I said, we're going to claim congruence on the basis of angle side angle, okay? We're going to look at this. We're going to take the information that's given. We're going to mark off our triangles accordingly, okay? So think about it ahead of time. G is the midpoint of FH. That means FH has been cut into two halves, two equal halves. Angle F and angle H are equal. Okay, is there anything else that's equal? All right, well, let's take a look. Okay, we have the vertical angles and two angles at G. So I mark it off. I mark off, okay, from the information given, angle F and angle H are equal. So I put a single curl through those to indicate that they are equal. Okay, based on the condition of the midpoint, based on the condition that G is the midpoint of FH, that meant FG and GH are equal. And based on the vertical angles, I marked them off. Do you think we have triangle congruence? Well, okay. How do you think one triangle is formed to the other? By rotating. By rotating this triangle on the left around point G into the triangle on the right. In which case, look what do we have matched up. Two sets of angles and the included side. That looks like angle side angle. Looks like angle side angle. Okay, let's try a proof. All right, we're going to have to work on these, so let's get a little start on it. Okay, here I'm giving you as a starter. Okay, some of the bits and pieces of it, and let's see what we would put in as the reasons and or the statements. Okay, it says BD is the perpendicular bisector of AC. Sorry, BD is the perpendicular bisector of AC. Now that says a lot. Okay, okay, so that must be the given. Okay, where do I get AD equaling DC? That's the definition of the bisector part. Definition of the bisector, or the perpendicular bisector. Now it says use the definition of the perpendicular, which would indicate that the two angles here at D, ADB and CDB, are equal. Definition of, okay, where does BD equaling BD? Well, that's our reflexive property right there, okay? And finally, says we can draw the conclusion that the triangles are congruent on what basis? We have the shared side, we have the angle down here, which is a right angle at D on left and right side, and then we have the segment AD and DC equal, to me, looks like side, angle, side, side, angle, side. Okay? So that's it, and we'll do more of this tomorrow in class.